Hello, and we are FSAE Electric Racing. I'm Xavier, the chief engineer, and we have...
My name is Eric. I am the human interface sub-team lead.
I am Ahmad, the assistant project manager.
And I'm Andrew Kingston, the project manager.
Okay, to start off, we'd like to give a little backstory of where FSAE Electric Racing came from and where we are now. So to begin with, we had Zeta. Back in 2012, it was a 3-year car, and the main purpose of Zeta was to build a running car. Next, we moved on to Electra. For Electra, we decided that we wanted to actually meet some more FSAE design requirements. And moving on from Electra, we went to Thor. Thor saw a little bit more electrical engineers on the team, which is how we got some more of the mechanical electrical systems integrating with each other. From there, we moved on to Joule, which saw the canvas. The canvas allows the vehicle to pretty much talk to itself amongst the different modules on the vehicle. Moving on from Joule, we have Lithium, which is this year's car. This year's car, we're moving on with a full telemetry system to gather any and all data that we could ever ask for, along with a new amazing aero package that we hope to help us out with any autocross events, along with a weight goal of 550 pounds. So some results that we had from last year. From last year with Joule at FSAE Electric Lincoln. As you can see, we're all the way at the bottom, 21st place. But and that came from a couple of complications with our cost report and a couple of components that ended up failing at competition, and we weren't able to receive the necessary parts in time to be able to fix those components. But I mean, if you look on the bright side, you kind of tilt your head a whole 180 degrees, and you're upside down. We're actually the top. So. And then to move on from there, our 3 main goals for this year's project. First one being to compete and meet all of the technical inspections at the FSAE Electric competition in Lincoln. That is the first goal. That is our main goal for this year. Next, we want to build a reliable electric race car. And reliable to us means maybe 2-5 years down the line, we can have lithium just come out of a storage container and be ready to go. Everything is still completely working intact. All you need to do is charge it, and you'll have the race car that'll be able to just do some driver testing just around the block. Along with that, we want to do some research and design for the future. And some of those research and designs for the future are our active aero that we're currently designing, along with a 4-wheel steering and our own battery management system. All of those will come in the future, and building those kind of new technologies will help further the FSAE vehicle and the competition.
So talk about some objectives for this year's car. A lot of these are really based off of iterations of our previous year. And we're looking to reduce the weight by about 80 pounds. Most of that is coming from the chassis and from the battery box of this year versus last year. We're also looking to implement a 12-volt system. We want to have our systems be able to integrate with, say, a normal automotive system. And 12-volt tolerance has been a milestone to allow us to do that. And also we've broken down, one of the failure points of Joule last year was that we tried to integrate all the systems together into one main system. We found that decentralizing the system and breaking down into separate modules has allowed for faster implementation as well as a simpler overall designs. We're looking to do that on not just the electrical side, but also the mechanical side with a modular suspension system where each of the wheel assemblies are actually the same assembly and it's just a different linkage system, greatly increasing our manufacturability. So if we were to bring this car into production, that would drastically reduce our costs. As well as doing that from powertrain, making it modular and also making it serviceable, so that the human time to build and assemble this car is greatly reduced, saving us time and money if this were a product. I want to address the organization. It's hard to read, and that's really because we're 63 active members. And the organization structure for that is we are fortunate to have 5 really passionate advisors, and then working with them is the mechanical, electrical, and project manager. Mechanical, electrical, chief engineers, and the project manager. Under them would be the 10 sub-team leads, which will address different types of designs. We do designs in aerospace engineering, materials engineering, mechanical, electrical, and computer engineering. And having different sub-team leads allow us to address the specific design constraints and concerns of those types of designs. And then as we go up to the top, the main work is integrating them into the overall system. And because we have so many different types of designs, I can't break down for you each and every one. So I want to give you a broad overview of how we approach these problems. One of the biggest parts is actually assessing your design requirements. For us, it comes from a rule book, which we have is like it's over 1,000 rules that we have to meet, as well as the requirements we gained from building a car. The requirements to have it compete to our specifications, or for reliability, serviceability, and we distill all those down from system requirements into individual component requirements that each of those 63 members would have their own component. And then we get design concepts based upon iterations of last year's car, as well as other applications of technologies that we can see parallels to how we could apply it to our project. And after we've chosen those design concepts, or we choose them through some called a trade study, which is basically just a down selection through a grading matrix to find out which would best meet our requirements based upon how we view our requirements. We go to manufacturing, which is both designing for manufacturing, which means we do design for manufacturing reviews, meaning we'll look at a design and we'll look how would we actually make it. Is it feasible? Could you print it that way? Could you bend it that way? How would you hold these fixtures together? And that allows us to move forward through the manufacturing process and start doing component and system verification so that we know we can meet our overall system requirements or objectives that we shared with you earlier.
Now moving on to the project timeline. Here, as you can see, we have a chassis that is fully welded, ready to go, and ready to be implemented for our current lithium car. Now, initially we had some setbacks in our electrical subsystem, which caused us to push forward our milestone for the PCBs being done and all the electrical tests being completed. So as you can see here, we have all of the designs are currently frozen so that they are being reviewed, being checked for accuracy, and making sure they meet the specific requirements and rules set by FSAE Electric and the competition rules. So as with that, we have just a few more milestones down the line coming up. As you can see, a rolling chassis that contains the car suspension system and a few human interface parts, which is the steering, the brakes and whatnot, and the tires and wheels and whatnot, along with suspension, as I mentioned. We have a running car deadline, which is closer to competition day. That was also something that we had to push back as a result of these subsystems being a little bit behind on their designs. But in the end, our main goal here is to build a car that lasts for the future, not the car that only works for one day. And further down the line, towards the end of the spring quarter, we have just some R&D, development, concept testing, making sure all of our designs have been designed for manufacturing rather than designed for design, and designed for simplicity rather than designed for design again. And moving on to our budget, as you can see here, a simple pie chart outline of all of our subsystems and what it would take to build this behemoth of a car. This electric vehicle obviously has very, very many components, so we did split it up into very many sub-teams. And the total funding required for our project is estimated at $32,000 to build this car. Now, $32,000 might seem like a lot, but a lot of this goes into competition, or going to the physical competition and building the car, and not having any, not having very many manufacturing sponsorships to be able to help us with the funding, as we have to resort to vendors and purchase orders more so, and manufacturing ourselves to help with decreasing the funding or decreasing the total budget required. And as of right now, we have $18,000, so we're about $15K short. So anyone here, feel free to donate. We can accept any and all donations. And moving on, we have our yearly progress. So we completed the chassis, fully welded, ready to be implemented. The aero and body and sensors team are currently molding the noses, which then we would go on, we would start with molding the nose, then molding the outer body, and then go on and assemble the wings. So that's how that would be constructed for the body. The powertrain is currently being implemented. The motors are being placed in the chassis to help with the rolling car and the suspension implementation in the next few weeks. As for batteries and electrical, they're working hand in hand. The batteries right now, we are currently in the stage of bending the box to be able to test fit in the chassis. And the electrical sub-team has most of their PCBs completely designed and ready to be manufactured. We are just waiting on a few parts. And as for telemetry, as you can see in the visual down below, we have 3 different GUIs of wireless transmission testing. Now, this is only being tested with the built-in antenna, which is capable of 300 feet, but we estimate that with external antennas, we can get the wireless transmissibility to be much, much further in the range, to be almost a mile, which is what our goal is for the competition, to be able to communicate telemetry data from the car to the driver and also to the team, or the pit crew, in real time. So thank you all for listening, and what questions do you have for us?